class of antibiotics that were previously licensed for the prevention and control of disease and also as food additives for growth stimulation. However, it was found that food produced from these animals contained residues that were toxic, and for this reason nitrofurans have been completely banned from use on several continents in food producing animals. Since nitrofurans are now classed as a zero tolerance substance, the methodology in place needs to be incredibly sensitive to detect very low levels in food, and for this reason we use LC-MS, which stands for liquid chromatography tandem mass spectrometry, which is just basically a very comprehensive and powerful tool that allows us to detect these levels. Since their ban, the majority of methods for nitrofuran analysis have focused primarily on just 4 main compounds, and the analysis has been very time consuming. So the objectives of my work were to extend the scope of nitrofuran analysis and also to reduce the sample turnaround times. So in my work, I've included an additional 4 nitrofuran residues. So now my method detects 8 nitrofuran drugs as opposed to 4 drugs. I've also made changes to the sample preparation approach. So traditionally, the majority of methods for nitrofuran analysis include a 16-hour overnight derivatization step that takes place in a water bath. This step is crucial because it basically converts the residues into a form that can be detected by our instrument. I've swapped this out for a microwave-assisted reaction, which has reduced the derivatization time down from 16 hours to just 13 minutes. I've also made changes to the extraction approach. So conventionally, the majority of methods would use a double liquid-liquid extraction, whereas now I'm using something called a Ketters-based approach. And Ketters stands for quick, easy, cheap, effective, rugged and safe, and that speaks for itself. It's just an incredibly efficient way of extracting residues out of food for detection. As well as it being a lot quicker, it's also greener because the conventional approach would use about 18 ml of solvent per sample, whereas now I'm only using 10. So all in all, this method is a lot quicker and efficient, and it has reduced the sample turnaround times from 4 days to just 1.5 days. So the impact of this work is that you're ensuring consumer safety and consumer confidence in their food, but you're also ensuring much smoother trade because food would have to be held at the likes of ports for much shorter times before it is deemed safe to enter into the Irish food market.